So I'm here with Rogue Research in Montreal, here with NeuroTechX at our second event, Industry, and I'm with Rock Como, who's the CEO of the company. The company has been around for a couple of years, and we're really proud to have them in Montreal, from Montreal. So we're going to talk about TMS, we're going to talk about FNIRS. So why don't you just explain a bit more about what a company does?
So in general, the main product is a neuronavigation system. The idea is that you can think of it as a GPS for the brain. We can do three-dimensional reconstructions of your subject, so the skin or the brain. So I can switch over to this type of view. So we have a unique type of reconstruction which makes it easier for people to see where they are. And the idea is that for brain stimulation, for example, we want to be able to define a spot in the brain that you want to stimulate with the stimulator. So for example, if I click here, I'll make that a skin just to give a sense here. This area of the brain is what's called the motor strip. And if I put a stimulator here and I fire the coil, we'll get a finger twitch. So we can activate the neurons in the brain that control your fingers. But that's an easy response. I can see something visual. But if you're a researcher trying to research something that's less obvious, not a motor, but vision or cognitive function, they don't have an easy way to determine or to ensure that they're at the correct target. So they have to use navigation. So they can decide by looking at the anatomy where in the brain they want to stimulate. We can define that as a target for stimulation. So I can call this a trajectory, for example. And I can record that location. So now I want to stimulate that spot. Sorry, the dot's a little bit small on the screen. Let me make that bigger. Right. So we can define a position and orientation to get the coil over the correct location. We don't have it here, but we use an infrared position sensor camera to track the stimulator coil on your head as well as your head. So we can display then as you move the coil where it is we're going to go. So if I just quickly go to a simulated TMS session, let's pick that target. I click perform. So I can move now the coil. Let me make this look nicer here. Skin, sorry. So as I move the coil over the head, I can see just a simple bullseye where we are. So that way, if I'm holding the coil on someone's head, I can move it around and I can see where it'll end up, right? So once you get the bullseye in the middle, we know that we're going to stimulate the target that we want to stimulate. So if I get a result from that stimulus, from my experiment, well, I can say with confidence that I stimulated this particular region of the brain and I got this response, and I can answer my scientific hypothesis. So that's a nice research tool. Brain stimulation is being used also routinely now for the treatment of depression and OCD and addiction. So the tools, though, to position the coil up until now have been very crude, where they simply use measuring tapes and bathing caps to decide where to go. But our customers, who are the researchers, are coming up with more elaborate imaging-based ways to map out individual patients' connectivity. So rather than just looking at the structure, you can light up a region. That's the circuit that you want to manipulate with the coil to achieve a clinical goal. So then you want to use navigation to get the coil over the right location. So we're now spinning up a new company called Elevate Biomedical, which is designed to take the research tools, redevelop it so that the interface is designed more for a streamlined clinical application. You just can't take a research tool, which is very flexible for different applications, and then move to the clinic. You need to be able to look at what's the clinical goal, what are the steps involved in using that properly and efficiently, using the same underlying technology, but a proper interface to make it more efficient for the clinic. And that's what we're doing now. We also have a next generation brain stimulator, which can stimulate the brain more reliably. So in brain stimulation, we're trying to either excite a particular brain circuit or inhibit a particular brain circuit to try and reestablish a balance. Every brain structure has inputs from different parts of the brain, and some inputs are positive and negative, and the idea is that we have a balance. And if one circuit's overactive or underactive, you want to manipulate it with the stimulator. So our next generation brain stimulator can do that more effectively than what's currently out there. So combining that with the navigation system, we have a next generation brain stimulator. For efficiency, we want to add a robotic arm to then speed up the whole process, where the patient can just sit down in a chair and the robot places the coil under the guidance from the navigation system, so that within 60 seconds of sitting down, you're beginning the treatment. So for the patient, that means a faster treatment. For the physician, that means more patients through the machine per day, which means you can treat more people. and it's more accurate because you eliminate the error involved in someone holding the coil. Even with a navigator, if you're sloppy with the coil, then you're not going to be very accurate with your stimulation. So we want to put all these things together into this new generation of brain stimulator, and then we want to see that go out into the clinic.
Awesome. So actually, you stole my next question about the clinics. So TMS was used in research lab a lot, and now in clinics with FDA clearance, TMS is gaining a lot of ground recently over the past couple of years. So who are now your customers? Is it more clinic or research labs?
So we decided as a company to, at least for Rogue Research, to stay squarely in the research side because the technology for the navigation now is not new. We've been doing navigation for 20 years. The key missing piece is that if you have a GPS system, what's the first thing you input to the GPS? A destination, right? So we know where we are, but we didn't know until recently where we're supposed to be to achieve the right goal. So it had to be the researcher who does research into brain connectivity and psychiatry to decide where they need to go and come up with a methodology to be able to do that for each individual patient. And that's just now coming. So it's maybe the researchers are doing it, they're publishing their first papers. It'll be something more commonplace in 2 or 3 years. So now we want to be ready in 2 or 3 years with an infrastructure to allow us to deploy these techniques into the clinic. So that's why we're making this shift. But up until now, selling a navigator to a clinic is really, it looks nice, but it's really not that useful. So we've avoided selling to the clinic because we don't want to sell a product that's not going to be useful, because then it works against you in the long run. You might make a few sales originally because it looks kind of neat and everyone's excited, but if they realize it's not doing anything for them of any value, then it sits in the back gathering dust, and ultimately that's bad for the market. So you have to enter the market not just with the technology, but the application that makes the technology useful, and that's really where we're going now.
Awesome. So thank you very much for being here with us tonight, and I hope you have a lovely time tonight. Thank you.